let's talk about this. So we have this world. We're given an endpoint and a midpoint, and we need to find the coordinate of that other endpoint. So if we think about this, right, we can do it two ways. You can do it sort of algebraically, or we can do it more visually. We're going to go with the visual method right now. If we want to go with the algebraic one. But if we think about it, it's like a translation. You're sliding one point to another, but we don't know what that rule is. All we know is only half of what happened. So if we think, what took us from 5 to -1, how much did we move on that? We subtracted 6. We moved 6 over to the left.
Wait, what do I do to find the -6?
So we thought, okay.
Is it 5 minus -1?
Other way around. It would be -1 minus 5, or -6. Or you can just think I'm moving 6 spaces to the left. It's the same thing.
Why would I move to the left?
Because we're dealing with x and we're going to the negative direction. And then because you start at 5, in order to get to -1, you would have to move to the left on your x-axis.
Oh, so you're at 5.
Yeah.
Okay, yeah, I get it now.
All right. So that it took us 6 to get over, but that's only half of our distance. So in order to get over the full distance, we would have to actually move 12. So if we start at 5 and we move 12 spaces to the left, where do we end up at?
Huh? Can you repeat that?
-7. So we start at 5. We're moving 12 spaces to the left. We end up at -7 if my thing disappears. We do the exact same thing with our y. So with our y, we start at 12. Halfway down, we end up at 4. So going from 12 to 4, how far is that? 8. So we went 8 spaces down, but that's only half the distance once again. So if we go down the full distance, what should that be? We're going down 16. So what we can do is we can take 12 down 16 spaces, or 12 minus 16. Where do we end up? -4. And there you go. So I have to do.
Is there going to be like a problem down this one?
Yeah, there was one similar to that.
Oh, no.
All right.
I don't think I'm going to be prepared for tomorrow.
So we'll have like the first half of the period to practice, and the last 20 minutes will be for the quiz. There's only 3 questions.
Oh, only 3?
Only 3.
So distance.
So if you miss one, you basically fail.
There will be a distance one where you have to sort of find perimeter, like what we did on.
What? Perimeter?
You don't have to do that. You think you
You're
did?
not gonna have this one.
You did that yesterday.
It's like a challenge problem.
Well, it's only one shape that you have to find the perimeter, and it's basically only 2 distances you have to solve for. Then there's one like this, and then there's something. There's an easy question of what we're going over today. Are we good with this warm up though?
Yeah.
All right. Let's keep going. So today we're going to talk about partitioning line segments. And so the word partition means to sort of create like a barrier, or to create like a in between. So like that wall behind us, that's a partition. It partitions both these classrooms into 2 classrooms. And so what we're talking about when we're talking about partitioning line segments is you're going to have a line segment with 2 endpoints at one point. And we're going to look for where can we make a partition to create a specific ratio. So say we're told we want a 2-to-1 ratio. We need to find where do we make that partition. So this line segment is 2 times this one, or it's a 2-to-1 ratio on these sides of the line. So that's what we're going to learn about how to do today. But before we can jump into that, we need to do a quick review about ratios in general. And so one of the things we need to do is we're going to take a ratio and we're going to turn it into a fraction to help us. But we need to sort of see a combination between ratios and fractions. So with this first one, I have a couple green squares, or a couple green rectangles, and a couple purple rectangles. I want to create a ratio of green to purple rectangles. What would that be? 3 to 2. But now if I look at it in a different way, if I were to look at green rectangles overall, what fraction of green rectangles is there overall?
3 or 5.
3 or 5. Okay. Do the same thing with the second one. We have that circle. How many green to purple? 1 to 3. What would the fraction of green overall be though? 1/4. And the last one's kind of hard to see because it's not very large, but what's the green partitions to 3 to 1, and then that fraction would then be 3/4. Okay. Now let's take a moment and think about this. What do you notice when you compare the ratio to the fraction in each of these situations? What was that? So your denominator is both the numbers added together. What's your numerator?
The first one and then.
So your first number will always be your denominator or your numerator. If you add them together, that'll be your denominator. Anytime you're given a ratio, you can always turn it into a fraction like this. So if I gave you 5 to 6, what would that be as a fraction?
5/11.
5/11. 5 becomes your numerator. Add them together to get your denominator. Are we okay with this? And this is a strategy we're going to use because with all these problems, you're going to be given a ratio. And what we'll have to do is we'll have to turn these ratios into fractions in order to multiply by them. And that's going to be something that's going to show up. So let's look at one of these problems. So with these problems, you're going to be given a line segment. So we have this line segment up here, and we're told we need to partition this line segment into a 2 to 1 ratio. So we want 1/2 of this line segment to sort of be 2 times as long as the other half, or the other piece of this line segment. And we need to figure out where that partition needs to go. Now with the graph, it's easier. So we're going to start with the graph, and then we're going to sort of work our way off of the graph. So before we start, though, we have a 2 to 1 ratio. Like I said earlier, we're going to change that into a fraction. So just like what we did on that last page, what would this do? Or how would we turn this into a fraction?
2/3.
2/3. So 2 becomes your numerator, 3 becomes your denominator. So we're going to use that 2 to 3 in this problem. Now, just like with that midpoint, if we think about this, we were thinking about sliding, sort of like a translation. You slid a certain, or we slid halfway and we were able to figure out how far that was and be able to find that other endpoint. If we look at this as a full movement of a full change of x and a change of y, what we only want to do is we just, rather than going double what we had in that midpoint problem, we're only going 2/3 of what we need to go. So we're going to look at what is this total change of x right here.
Like literally counting.
Yeah, what is that?
6.
6. What is our change of y?
33.
So that's the full distance. But with this, to get our 2 to 1 ratio, we only want to go 2/3 of that. So I'm going to take 6, and I'm going to multiply that by 2/3. Now, how do we multiply fractions?
You make your little whole number a fraction bar by putting it over.
So I can take 6/1, good.
You need to go straight across, right?
Straight across, yeah. So you take your whole number, turn it into a fraction by putting it over 1, and then we can just multiply straight across. So 2 times 6 is 12, and then 1 times 3 is 3, so 12 divided by 3 is 4. If you don't want to have to make that whole number into a fraction, another quicker way you can do it is you can do 6 times your numerator, which is 12, divided by your denominator of 3, which is 4. And that's another quick way to do that, rather than having to write all this out. But either way, it's the same thing. So that's our change in our x is 4. We can do the same thing for our change in y. Our y was 3. We're going to multiply that by 2/3. So once again, we can do 3 times 2 is 6. Divided by 3 is 2. Or you can think you have a 3 in your numerator, 3 in your denominator. You can cancel it out. Same thing. So we're going to go 2 up. That's our partition. What's that coordinate?
1,
1. So with the graph, pretty simple. We're able to just sort of count those spaces, move along that, and be able to move that transition that we need to go. It's going to get a little bit harder, or we'll have to do a little bit extra work when we're not given the graph. So say we're just given 2 coordinates. So I have -5, 0, and 1, 4. I'm given my ratio of 3 to 1, and we need to find that partition. So thinking back to that last problem, what was the first thing we did? We converted our ratio to a fraction. So 3 to 1, what does that turn into? 3/4. Okay, so we'll use that. Now, if we think back to our last problem, the next thing we did is we found what was the change in x. So we looked and so we were able to count on that graph. But on this, we can't necessarily count. We can't really count the change of x. We can't count those 6 spaces over. But if we think about it, change of x, change of y, those are words we use in Algebra 1 whenever we were talking about slope. And we would calculate what was our change, like a rise or a run, what was that change in x and that change of y. So what we did in Algebra 1 in order to determine those numbers is we would take x2, your second coordinate, minus x1. Or if you were looking for your change in y, we would take y2 minus y1. That gave us our sort of change in our x and change in our y whenever we were doing that rise and that run, if you just had the coordinates. Or when we were trying to calculate slope or rate of change. So let's think about this for this problem. So what's my x2?
1.
What's my x1?
-5.
So I have 1 minus -5. So good, because I'm subtracting by a negative. This is the same as adding. So this is the same as this. I can do the same thing with my y. So y2 is 4 minus y1, which is 0. So that just gives me 4. And that gave us that sort of change in x and change in y that we were using on the graph. Okay, so now we have this information, those changes. The next step we did on the last problem was we multiplied by our fraction. So we took our fraction, we only wanted a portion of that change. So I'm going to take this and multiply it by 3/4. So we can think 6 times 3 is 18, divided by 4. You might want to use a calculator for that one, but it's going to come out to be 4.5. Same thing with 4. 4 times 3 is 12, divided by 4 is... Now this isn't where we stop though. So this is just how much we're changing, but what point are we changing from? What point are we moving over from? We're starting from -5, 0, rather than just like starting from origin. So what I need to do is I need to add on my original coordinate I started with. So I'm going to add on -5. So 4.5 plus -5, where does that end up? -0.5, because you're 4.5 positive, basically it's -5. And we'll do the same thing. So I start from my original y coordinate, which was 0. I'm going to add that on to my change. So 3 plus 0 is 3. And so my final solution would be -0.5, 3. That would be the coordinate for that partition of the 3-to-1 ratio. So it seems like a little bit more work than the last problem, but if we turn this into sort of like a formula or like a method we can do, we can trim this down to sort of, we can break these out really quickly. So let's sort of think about the steps we did and try to sort of create a formula. Let's try to derive a method that we can go by. So step number 1 was changing that ratio into a fraction. So that should always be your first thing. But after that, we looked at our x's. So we took that x2 and we subtracted that x1. We did that change of x. So we got a number from that. From there, we took that fraction, that ratio, and we multiplied it by that ratio. So we found the change of x, multiplied it by the ratio. So in our last one, that was 4.5. Last step we did, we added our original x coordinate back into it. We added that -5 into it. And that was our solution for that x. Same thing for the y. We took our y1, or sorry, our y2, subtracted our y1. That gave us our change in y. Took that number, multiplied it by our ratio again, and then added that original y1 back in. So original y1 in the last problem was 0, so it didn't really change it. But that gave us our y1. And that's all you have to do. So if you use these steps, or this method, this formula we just derived, that should be able to solve any of your problems that you could have. So it's just like our distance formula, just like our midpoint formula, same thing. It's like another, you can call it the partition formula if you want.
Are we going to have to memorize these for tomorrow?
Yes. But we have today and beginning of tomorrow to practice through that. And the goal is hopefully by the end of today, you won't necessarily have to look back at this. You'll just have like, okay, I know I need to do this next. I know I need to do this next. And you'll just be able to write it out. So we're going to practice this. Are you still writing it down, Amanda?
No.
Okay. So let's use this on a problem. See this in action. So first things first, I have coordinates. I need to find this partition for 4 to 1. So I'm going to change that 4 to 1 first. So 4 to 1, that's going to become 4 in my numerator. 4 plus 1 is 5 in my denominator. So 4/5 is my fraction. Now I need to think, okay, so my formula is x2 minus x1 times our ratio plus x1. So let's start filling in some information. What's my x2 that I know? 5. What's my x1? Negative 5. So I have 5 minus negative 5, and then it's going to be multiplied by my ratio of 4/5, and plus my x1 again, which is negative 5. So now that I have all this information plugged in here, I just have to simplify. It's like plug and chug. Plug in your information, solve it. Just like what we did with the quadratic formula last year. Plug in all that information, simplify. So let's think. 5 minus negative 5. I'm subtracting by negative, so it's a positive once again. And good, so it'll be 10. We're going to multiply that by 4.5. So 10 times 4.5. You can think 10 times 4 is 40. Divided by 5 gives you 8. Last step, add negative 5, which is the same as minusing by 5. So 3. That's our x coordinate. Okay, good. So it's one coordinate. All we have to do is do it again. So we think, what is our y2? Negative 2. Then subtracting our y1, which is 3. We're going to multiply that by a ratio once again of 4.5. And then add that original y coordinate back on there of 3. Let's see what this equals. So negative 2 minus 3, negative 5. So we're going to multiply that by 4/5. So I have a negative 5 and a positive 5 in my denominator. So those can cancel out. So I'm just left with negative 4. So negative 4 plus 3 gives me negative 1. My final solution, 3, negative 1. That's my answer. So if you can use that formula, you can crank these out really quickly. Plug it in, check. You can even type this whole thing into the calculator if you wanted, and just hit enter, and that can solve it for you. Just as long as you can set it up right, it should work out. Are we okay with this? Want to try one on your own? All right, so you have a ratio of 1 to 3. Here are your two coordinates, negative 2, 3, and 6, 1. Okay, so what do we come out to as our final solution? 0, 2.5. Awesome. What did you get for your final solution? So if we think about it, it's, let's see, y2 is 1 minus our original of 3. That gives, and then times the ratio of 3/4. No, 1/4, I'm sorry. 1/4. Then we add on that original y back in there of 3. So 1 minus 3 is negative 2.
Well, then why is it, that's nice.
Did you have your point switched on or something? Yeah, here to continue with that, negative 2 times 1/4 gives you negative 0.5, plus your 3 on there, that gives you 2.5. Yeah, I assume you just have the point switched around, but put it back to normal, should be good. Are we okay with this problem? Alright, so we're going to look at one other style situation. So that was, you're given a line segment, you had to find that partition. But it's also possible to have something like this. So you have a point A, and that point is at 1, 2, and then point B is at 7, 6. So we need to find the coordinate of a point C that makes AB to BC a 2-to-1 ratio. So let's try to dissect this and figure out what it's talking about. So you have a point A. There's a point B. We want to make this ratio of A to B 2-to-1 compared to B to C, or whatever that C is. So we need to make this a 2-to-1 ratio. So rather than finding a partition that's on our line, we're finding one that's off of the line in a sense. Or they sort of gave you the partition, you need to find that other endpoint. It's like that backward thinking that we've been doing before. Luckily, there's only one thing that we have to change. It's a very minor difference. So we're going to do that exact same thing, that exact x1 minus x2, or x2 minus x1 times r plus x1. The only difference we're going to do is that r, instead of using your normal ratio of 2-to-1 being 2/3, the only thing we're going to do differently is instead of using this, we're going to take the reciprocal. Rather than finding a fraction that's on here, we're making this a fraction of the whole. So we're going to flip that upside down. We're now looking for a 3-to-2 ratio. And that should help, or this should give us our partition for C. And that's the only difference you have to do. Everything else you do will be the exact same. You just have to remember to take the reciprocal of that ratio. So I can plug it in just like I did before. My x1, my x2 is 7 minus my x1 is 1 times my ratio of 3-to-2 plus my x, which is x1 is 1. All right, 7 minus 1 is 6 times 3/2. 6 times 3 is 18. Divided by 2 is 9. Plus 1 gives me 10. So I know this coordinate will be 10 something. We know with our y. Same thing. y2 is 6 minus y1 is 2. Okay there, Cole? Is that you? Rocking back and forth? Alright, so 6 minus 2 is 1. Or, I'm sorry, 6 minus 2 is 4, but we're going to multiply that by our ratio of 3/2, and then add that original y1 back in there, which was 2. So 6 minus 2 is 4, times 3/2. 4 times 3 is 12, divided by 2 is 6, plus 2 gives us 8. So our final solution is 10, 8. So the only thing different that we're doing for finding a point that's off that line is taking the reciprocal.
Would that be on the list?
But I still want you to be able to do this because they gave one like this on a practice geometry state test. And so you might see the problem with this in your state test. Just trying to prepare you for your future. So I'll give you one of these to try and remember. Once again, the same thing. The only thing you're doing differently is that one. So we have x is at -1, 3. Y is at 1, 5. Find the coordinates for point C or Z that makes xy to yz a 2-to-3 ratio. I can pause this and give you a moment to work on that. All right, so on that we should have ended up with 4, 8 as our solution. Good?